Today we are going to be comparing a significance test to a confidence interval. So it'll be a good review for doing both and how they compare to each other. Because this test you can be prepared to see both of them showing up together. So we're looking at 49. This is page 563 if you have your book, and it's asking us to do a significance test. So what I'd like you to actually do is take out a sheet of paper, and we're going to have the teacher pause this. And for 10 minutes, what I want you to do is do this problem. It's a significance test, and you're going to make the decision. Is it a mean? Is it a proportion? Write your HO, do everything, and practice what everything would look like. So we're going to have you do that for 10 minutes. Don't look at your notes. See if you can handle this, defining variables, all that other fun stuff. So I'm going to have the teacher pause this for about 10 minutes. And then we'll come back and I'll show you the answer. So I'm going to show you my results now for this, and you guys can kind of grade yourself and see where you're at. So things that have to be there, sorry, I'm trying to get this. So notice, you've got to make sure you define your HO and HA if you're doing a significance test, and tell me what pi is. Okay, so I wrote some variables up here just to organize my thoughts, but this is the stuff that has to be done. I'm going to have a title. Conditions for I'm going to move that off to the side. One sample proportion Z test. Number one, simple random sample. Number two, probably you should do that 100 times. You've done it, you're good. Now I get to number three. Now this is a proportion, and so if you had mu's and x bars and s's, you're wrong. You have to make sure. Proportion is number of successes out of the total. So we were looking at, do you see that x over n, 86 people of 125? This is a proportion. So when you get to the third condition for proportions, well, now we've got to go with the n times pi or n times p hat, depending on what we're doing. And if you have pi, you use it. So n times pi, notice I do that, 75, 50. Both of these are greater than or equal to 10, so a normal approximation is okay. So I draw the curve. Two-sided test. A two-sided test means you're shading both sides of the curve. So 0.5, the same distance over here is the same distance over here. So I'm shading both sides. Now my formula, and I'm always going back to this lime sheet. The formula, page 5, is your go-to. You're on a test. Statistic, English letter, minus parameter, Greek letter, divided by the standard deviation of statistic. I'm on a proportion. This is the standard deviation of the statistic. Notice p's are pi's. If you have pi, you use it. If not, you use p hat. So p times 1 minus p over n. Okay, so that's where I'm piecing everything together. Statistic minus parameter divided by the standard deviation of the statistic. Formula, substitution. Now I go to the calculator. So stat test, and I'm doing a one proportion Z test. If it's a proportion, the calculator better say proportion. So I'm going to number 5. Press enter. My null hypothesis is 0.6. Notice they're not asking for what p hat is. P hat is 0.69. They're asking for how p hat was computed. So they took 86 out of 125. And then I hit calculate for not equals to. Okay. Write down your z value, write down your p value, and make your conclusion. So my z value is 2.01. My p value, sorry, I'm trying to hide that piece, is 0.04. Whoa. I'll just show that to you, kind of cover this up for the time being. So z is 2.01, p value is 0.04. Now I write my conclusion. I'm plarting, Plartis, Since the p-value is less than alpha equals 0.05, we reject HO. So that's the first sentence. Second sentence talks about the alternative hypothesis. Or I go back to the sentence that was written in the original problem. There is sufficient evidence to conclude the DMV's claim is incorrect. I could either write this sentence, or I could just say the alternative in words. There is sufficient evidence to conclude that the true population proportion of drivers who pass their test is not equal to 0.60. So that's another way of writing it. So now what I want to do is take a look at number 51. And I'm not going to zoom in because I'm having trouble with my zoom feature here, but if you look at 51, 51 is asking you to do the exact same problem, but this time they want you to construct a 95% confidence interval and look at the interval. So let's do that. Okay, now it's been a while since we've done confidence intervals. Hopefully I was here for those. So let's look at a confidence interval, okay? We're going to turn this problem with the exact same data into a confidence interval. Now when you do a confidence interval, remember, you don't have pi. So that's out there. All you've got is your statistic that you're going to try to estimate what pi is. Now if I'm doing a confidence interval, you do not have HO and HA. What you do have, though, is you better make sure you define the Greek letter for your, that goes with your statistic, whether it's a mean or a proportion. So where pi is the true population proportion of teens who pass their drive, you have to have that written down. So things that change. Conditions for a one sample proportion, 95%. Confidence interval. You don't have to worry about degrees of freedom because you are not on a mean problem, so just 95% confidence interval. 1 and 2 stay exactly the same. Now, when you get to the third condition for proportions, the problem is that for confidence intervals, you don't have pi. So this is actually going to change to p hat and p hat. So you're actually going to do 125 times 0.69. Okay, and what you might even want to do, I don't know if you guys have it readily available, but go find your confidence interval notes and see if you can compare a test to a confidence interval, and you'll see these slight changes. So 25 times 0.69 becomes 17.25. That's not right. 125 times 0.69 is 86.25. And 125 times 0.4 is 50. No. 125 times 1 minus 0.69 becomes 38.75. And both of those are greater than or equal to 10, so a normal approximation is okay. Now, what I have here, let me actually just kind of slow it down here. So this is what it would look like for a significance test. For a confidence interval, you don't have pi, so you can't put pi in the middle. So the only thing you can do is put 0.69 in the middle. And your job is to find out what those numbers are right there. So I go back to my Lime sheet. Confidence interval, statistic English letter, plus or minus critical value times the standard deviation of the statistic, which is right here for proportions. Now, normally p's are pi's, but we don't have pi, so you have to substitute in p hat. So look at the formula compared to each other. I'm just going to leave that there. Well, you can see all that fun stuff. So, notice statistic plus or minus the critical value z star times the standard deviation of the statistic. Do you see this formula has pi in it because you had pi? Over here, when you're doing a confidence interval, you don't have pi, so you have to use your p hat, which is the 0.69. So formula, substitution, don't forget the z star. That was back in confidence interval. Where do we find that? How many standard deviations have we gone above or below? So 95% on page 16. 95% for a z value, no degrees of freedom, you just go right to that one, 1.960. Now I go to my calculator. Stat test. I've got to go down to intervals. Remember, if it's a proportion, it better have the word proportionate. This is one sample proportion. And x is 86. P hat, remember, it's not p hat, it's what fraction creates p hat. 86 out of 125. And we are doing a 95% confidence interval. We're going to hit calculate. So let me get these numbers down, 0.606, 0.607, and 0.769. So 0.607, that's where you would make your conclusion from. Okay? So that will sum up how you make conclusions of confidence intervals from confidence intervals that that make the same conclusions as significance tests. Please be careful, because there are going to be problems on your homework that want you to do them as confidence intervals, and if you have confidence intervals, you don't have mu or pi. You don't use them. You can make conclusions, but you don't use them when you're creating your problem. So hopefully that helps, and also it's a really good review. And this chapter is going to have, on the test, you're going to be asked to do significance tests and confidence interval, and that's going to happen when we get to the next chapter, I think, which is chapter 10, if I'm thinking right, where we're going to be mixing up the two, and you're going to have to keep everything straight as to which one is which. So it's good review, but but there's a lot of stuff going on. So try to listen to the little tidbits that I'm giving you. So hope it helps. I will, you guys have a good day, and I will be seeing you in a video sometime next day. Goodbye.